All right, for chapter 10, we're going to be starting looking at energy balance and weight control. When we think of weight control, a lot of times we do think about a situation where we may have too much weight, being overweight, or perhaps even in an obesity category. But you could also look at weight control or weight balance if an individual is underweight. And so we'll look at both of these situations. The first one is overweight and perhaps even obesity. Both of these are problems in the U.S. and other places around the world, and so you have a definition there for obesity. We'll try to define it based on the body mass index that we'll talk about. But obesity is where the individual has excessive amounts of body fat. This is unhealthy, and it usually could potentially lead to other problems, such as cardiovascular issues, depending on their diet and things. And so, the question becomes, well, how do you measure that? How do you categorize uh, if someone is overweight versus obese? And so there are a couple of um, criteria to try to look at something like this. And one of those, maybe not the only way, but one of those is looking at what's called the body mass index. What this is a ratio that tries to look at an individual's body weight that has a correction there for their height. And this is not the only way to look at someone's overall health. There's many different factors, but it's just one tool that's out there to kind of give you a quick number. It's not always maybe reflective, 100% accurate, reflective of the individual's overall health, but there is some use in looking at someone's BMI. We'll talk a little bit more about the calculation as we go through, but you can see it here. There's different ways to calculate it, but it's always a ratio based on weight and height. And the way I have it here is in like US units. If you know the person's weight in pounds, if you know the person's height in inches, you would square this number first, and then take their weight and divide it by that number multiplied times 703, and that gives us your body mass index. But I'll show you another way to look at this as well. I know this statistics here is a little outdated. According to your textbook, 2017 to 2018, they estimated about 42% of American adults were in the obese category as it applies to the BMI chart. And I'll show you a table a little bit later on. That's a pretty significant number. Like I said, it's a little outdated. I haven't checked to see how this number has compared, over the last 4, 5, 6 years. And so, but again, this is a significant number of adults that fall into obese category. And so there we do have a problem generally with nutrition and or lack of physical activity. Section 2 looks at a couple of things to look at and measure as far as body composition. And so two main areas that you would look at is how much body mass is there that's talking about fat-free type of mass. So the lean tissues. So that includes things like the body's water. We talked about in chapter 9 the overall hydration for the body. That constitutes a lot of mass for the body. Mineral-rich tissues, in other words, something like our bones, that's a significant amount of our overall mass. Protein-rich tissues, muscle tissue. But a lot of times what we're looking for as far as an overall health nutritional value is to kind of look at the total amount of body fat in the body composition. And so what we're talking about mainly is adipose tissue. You find a lot of this in the underlying skin tissue. So underneath the skin is you have a layer of adipose tissue there. And then you have fat in other locations in the body. It's part of our cell membranes. You have some stored in some of your bones. Some of your long bones have this stored there. You've got some in your nervous tissue. So it's essential in different places, but the majority is going to be found in the adipose tissue. So how do you quantify body fat? Well, there's some different ways to look at that. And so your textbook kind of goes through a few examples here. some of these, as we go through them, we'll kind of see the pros and cons of each one, and we'll kind of end up talking about two main ones that are used, and we'll kind of see the reasons there. But number one here is what's just underwater weighing. And so again, it's kind of a ratio comparing the weight to a person outside of the water, and then compare that to their weight is completely submerged, and that can give a pretty accurate measurement of the overall body fat composition. The problem is this is not a very easily accessible way to measure body composition. You would have to go to a specialized location, office that had this type of facility there. So it's very inconvenient. It's not very practical, but it does give you an accurate measurement there. The second one we'll look at is something called dual energy X-ray absorptiometry, DXA. And you can imagine this type of a scan would be very accurate. It's using X-rays to actually go through and scan the body and detect body fat composition. But as you can imagine, this is very expensive, and you're not going to see this used very often, maybe in some research type settings. The third one here, air displacement. Again, there's some issues here because it's also very expensive. It's very only seen in certain research type applications. But it's worth mentioning here the individual here, the patient would sit in what's called a bod pod type chamber. It kind of looks like an egg type chamber here. And basically it's looking at, it's similar to what's looking at with the water displacement, except it's looking at the air displacement. So it's measuring that air in the chamber, kind of with the person inside and with the person outside, and it gives kind of an overall body fat composition there. Now, a little more practical here is something called bioelectrical impedance, and you may have seen this before. I know some of our health science and health fitness program students are familiar with this. You may even have a home device that measures this. Bioelectrical impedance is basically a very small, very weak electrical signal that goes through the body. And as it does, it can calculate and give you a measurement of your body fat composition. It's fairly reliable. You can even find this in home devices. And so you can do a search, you can look on Amazon or wherever you look online, and you can find devices that are relatively inexpensive that will measure body fat composition. It gives you a percentage of body fat. Sometimes they give you, they may not be accurate if your hydration status is low. So if you're a little dehydrated, then it can give you an error message there. And so, and again, there's some home devices you can purchase online, relatively inexpensive, but there's some question as how accurate that would be. I've also seen you can buy scales. So if you're weighing yourself and just getting an overall weight, they'll have little conducting plates at the bottom of where you stand on the scale, and that's can actually measure your bioelectrical impedance, and it gives you a measurement of not only your weight, but also of your body fat composition. And it'll probably give you BMI also if you key in the information that you need. Another practical way, and is used routinely, is using basically a caliper, a device here that's going to measure the thickness of your skin. It's measuring how much fat, and again, this is looking at adipose tissue. So it has some problems that it may underestimate total body fat because it doesn't get all of the. It's just a rough estimate, really, because it's not going to measure any fat anywhere else except for that adipose fat that we mentioned earlier, just under the skin area. But again, it's relatively easy to use. You can be trained on how to use this. You can go to a gym and they can use, they can measure this for you, and it's very inexpensive. You see different estimates of what's healthy, what's overweight based on body fat compositions. And you can kind of see here separated by males and females here. Healthy for males, around 13 to 21%. You do have kind of a wide range there. Their suggestion here is that if you're in an overweight category, then your body fat is probably higher than that 21%. And they, somewhere around 22 to 25. Obese, they list as 26 to 31%. And then above that would be an extreme category of obese. Section 3 is going to look at energy intake, our energy levels, and which goes into, how much calories are we taking in versus how many calories are we, expending, burning. And so Section 3 kind of reminds us about these nutrients, these macronutrients that we've talked about in the previous chapters. These are our fuels for our body. And so if you're talking about carbohydrates, the glucose, that's a major fuel for our body. That's where we're getting that energy to go through all the different chemical reactions, muscle contractions that our body needs to do. So mainly we're getting that energy. Those fuel sources are from carbohydrates, glucose, simple sugars, and of course fatty acids, the fats, because you can convert those into energy very easily and even store that as energy. You can, and your body does, and we mentioned a few things about this before, take proteins, digest the proteins into amino acids, and then you can metabolize amino acids to use as energy sources also. But for the most part, the higher percentage of our energy sources coming from simple sugars, glucose, fatty acids. They estimate about 40% of this energy from these macronutrients, carbohydrates, fatty acids, and even a little bit of proteins, is being used for that ATP molecule, right? So, in other words, it's only about 40% efficient creating that ATP energy that we need. So a lot of the calories go into producing and releasing a lot of heat energy. It's kind of like, I think of like an automobile, the engine inside. How much fuel efficiency do we get out of a gallon of gasoline? Because a lot of the energy, your engine is converting, that fuel into mechanical energy, but it's not 100% efficient. I don't know how efficient it is or inefficient it is, but you're using up a lot of the energy is being escapes out as heat. Same thing with our bodies. Now we are using some of that heat because our body temperature, that's 98.6 degrees Fahrenheit, 37 degrees Celsius. So our body needs that heat, and we're using that heat because that's how our chemical reactions inside of our body, they progress a lot quicker with a warmer temperature. So that the heat is important, but only about 40% really is being extracted from those macronutrients be actually used in the ATP molecule. You'll see this definition here, basal metabolism. We think of our metabolism as, all of those chemical reactions taking place in our body and the energy that's needed. The definition there for basal metabolism is, what's that minimum number of calories, the energy units, used for your vital physiological activities, things like breathing, respiration, things like digestion, going through digestion, even some, your heart beating, that's muscle contractions. So all of these things, while you're sitting there at rest and you're not eating, that's your basal metabolism, right? So just kind of imagine you're sitting there, you're really not doing any kind of work, you're really not exercising or anything. Your body is at rest, but you're still using energy. You're still going through some activities that, physiological activities that still require the burning of energy and calories. And so the measurement of that measurement number is known as the basal metabolic rate. And you can measure that or kind of estimate that based on some couple of criteria. In general, the rule of thumb, in general, men tend to burn a few more calories at their basal metabolic rate, the BMR, at about 1 kilocalorie per kilogram of body weight per hour, which is not very much, but just to say that, hey, your basal metabolism, how much energy just at rest is your body using just to go through its vital physiological activities. Go through, again, things like your breathing, that's using muscles. Your heart is beating, that's using muscles. Even things like muscles that are helping you. If you're sitting down, that's still requiring muscles, like lower back muscles, to support the body. And so that's requiring some energy, and it's using some calories as well. You could go online and find a BMR calculator that looks at other criteria, and it kind of looks at, you can key in what the person's weight is, their height, gender, all these different aspects of the individual to get a closer estimate of the basal metabolic rate. And so anything that we do physically is going to be above that basal metabolic rate. And so once we get up and start exercising, we move some of our skeletal muscles, those voluntary, those ones that we control, those muscles that are attached to our skeleton, and we're going to start burning more calories. So how many calories are we going to burn or expend? Of course, it's going to depend on, well, what are we doing? Are we doing some type of physical activity like walking, or are we, sprinting and jogging really fast, or running fast? How long are we talking about? That's going to depend on, or that's going to determine, how many calories are we expending above the basal metabolic rate? How intense is the exercise? Are we talking about, doing something like lifting weights that's going to use a lot of calories in the muscles? Or are we talking about swimming that's really a full body type workout exercise? Or are we, again, thinking about just walking or casually doing some physical activities? And of course, the weight of the person can affect that as well. The non-exercise activity thermogenesis, or NEAT, again, this is kind of physical activity that we sometimes forget about. Just activities like standing. That's using up some calories. That's using up some muscles that allow us to support the weight of our body if we're standing, or if we're walking in a classroom, or we're walking in a hallway, or walking around the house. That's not exercise, but it is movement. So therefore, it is burning calories and expending that energy there. So these would be activities that NEAT here, non-exercise activity thermogenesis, any kind of activity that's not considered exercise, but that does contribute to some caloric expenditure. Last thing I'm going to kind of look at in section 5, they have that BMI. We talked about the body mass index, how this is a value that tries to reflect it's a ratio basically of someone's body weight and height. And I've got two different formulas here just to kind of show you. If you looked at the metric system, if you know the person's metric weight in kilograms, and if you know their height in meters, you would square the height so that you would have their weight in kilograms divided by their height squared in meters. And that would give you that BMI number. And I've already showed you if you're not using metric, if you know the individual's weight in pounds, you square their height in inches, and then you have to multiply by correction factor to convert it to metric, and that'll be 703. This is either one should give you an approximate value for BMI. I had a little example here. You can kind of practice this. I didn't write out everything, but if you try to calculate someone's BMI, you know that their weight is 150 pounds. You know the person is 6 feet tall. So if the person's 150 pounds, then you can plug that up right here to this formula. No problem there. If they're 6 feet tall, multiply times 12 to get it in inches. And so that would be 72 inches. Remember, you have to square their height for either formula. So you square their height. If you're looking at this problem and you square their height in inches, 72 times 72 is 5,184. And then we said that their weight was 150 pounds. So 150 divided by 5,184. When I did that on my calculator, I got 0.289 and some other figures there. And so remember, you have to multiply that by 703. And I get approximately 20 as my BMI, or 20.3, and you can round. That would be fine. So around 20. Now, you can also look up, and I found, there's many different charts that have this kind of done for you already. And so if you wanted to kind of quickly, the individual's height and their weight, and this again is in pounds. And so for that same example, the person's height is 6 feet tall, and that the person's weight is 150 pounds, and then you go down and it comes out to right about 20. They just rounded all these numbers here. You can also find many different apps. You can go online and you find calculators, you key this in, and it'll give you that measurement right away. The last thing I want to look at here is the effects on our body if we do have excess body fat. And so one of the things that research has shown is that there can be correlations between individuals' BMI, if it's in a certain category, and other health concerns. So they found that if an individual's BMI is greater than 25, they have an increased risk for something like type 2 diabetes, or hypertension, high blood pressure, or other cardiovascular problems, including heart attack or stroke, and even something like osteoarthritis. They found additional problems that are associated or correlated with individuals that have BMIs greater than 30 with things like certain types of cancer, or problems if they have to have some kind of surgical procedure, they may have certain complications. They have other heart-related issues, or sleeping issues, or fertility problems, or diabetes if they become pregnant, gestational diabetes, or poor mental health, low self-esteem. All of these seem to have some connection between individuals that have higher BMIs